Hey guys, welcome to Two Data Detectives. Today I want to talk about code vulnerabilities. My partner Daniel is a web developer and he helps history and architecture researchers visualize maps of Australia on websites. Every time he has a new deployment, he needs to submit for a security review. The security reviewers would run a set of tests and give him a list of vulnerabilities. However, that list only has the categories and it doesn't say where in his code has the vulnerabilities because the reviewers don't have access to his source code. Daniel is not a security expert, so it usually takes a lot of back and forth with the security team to diagnose the problems in the source code and pass all the tests. So Daniel wants to know, can generative AI help identify code vulnerabilities? My first reaction was, have you tried GitHub Copilot? But Daniel said this is work code, so he can't risk Copilot taking it and use it for training in the future because that will be IP violations. I think what could work for him is a private large language model service. It can be locally hosted or a large language model service that we know that's not going to use the user prompts for training. We can pass the code to large language model and ask it to identify vulnerabilities in the source code, which line it is, explain it, and how to fix it. This way, Daniel can already rectify a lot of the vulnerabilities in his code before he submits for a code review. With generative AI, this could save a lot of back and forth with the security team. In this video, let's explore how large language models can help with the identification and also the education of code vulnerabilities.
Okay, let's get started. The first step is to install the required libraries. In this example, we use .env and IBM Watson machine learning because we want to use Watsonx to host the large language models. So let's install that. Because I use some of the code that was in IBM Watsonx in the prompt lab, so I'm keeping this title here just for reference. I save my API keys and project IDs in the .env file. Then we're going to create a get credentials object to store our credentials. As for how to get the API key and project ID, I'll post the link below in the comment so you can follow the instructions to get your keys and save them in your .env file. Next, we can go to inferencing. I'm going to use Llama 2 as the large language model because I know it's quite powerful. I think it's going to work here. First, we define the model parameters. In here, we're going to use decoding method greedy. This means that the model is deterministic. Max new tokens is a parameter, and it means that the maximum number of tokens the large language model is going to output is 2000. Next, we define the project ID and the space ID, and we define the model object. Next, we can define what we're gonna feed into the model. So this is the prompt. This is a typical format for prompting Llama 2. So what I'm saying is, in the system prompt, I'll tell the model you're a code security review assistant and you identify all of the security vulnerabilities of the given code in the format of the type of the vulnerability, the line of code that has the problem, explanation, and how to fix it. And I said, if you're unsure about the answer, truthfully say, I don't know. And for the prompt, I give this PHP code. So let's feed this to the model and see what happens. During execution, say model generate text, and we'll print the output. Now we have the output. Let's have a look if it makes sense. So it has identified 1, 2, 3, 4, 5 vulnerabilities. I know that this example code is about past traversal vulnerability, which happens here. And you can see that the large language model correctly identified this vulnerability and it has given an explanation and how to fix it. So that does make sense. What I've also noticed that there is a false positive here. Number 3, SQL injection vulnerability. And it says that this input can lead to an SQL injection. However, if you go back to the code, there is nothing about SQL, so that is an incorrect vulnerability that has been identified. But apart from that, the rest of the vulnerabilities look like they make sense. So that's a kind of successful example. There's one false positive.
Thanks for following along so far. In the next video, we're going to look at more code examples and more types of vulnerabilities. We're going to use Python to automatically load files for scanning instead of manually copy-pasting code into the prompts. Please stay tuned and see you in the next video.